We can paint the world a beautiful picture, hold it up for everyone to view.
Solving systems of equations is going to be our next unit, and we will be dealing with the elimination and substitution methods after the midterm. They are algebraic. However, graphing kind of bridges both units that we've been working on. So we're going to talk about that a little bit tonight. Looking in your notes, what is a system of equations? Well, if you look at Charles Dodgson, better known as Lewis Carroll, he actually loved math, and he incorporated a lot of math and science into his storybooks. If you look at a passage through the looking glass, Tweedledum said to Tweedledee, the sum of your weight and twice mine is 361 pounds. Tweedledee to Tweedledum, contrawise, the sum of your weight and twice mine is 362 pounds. That, my friends, is a system of equations. So it is a solution that works for both situations. The solution is the point where the two lines intersect. Now, we could have a system of 3 equations or a system of 4 equations. Graphing, we're going to do 2, but algebraically we'll do more. All right, the sum of 2 numbers is 4 while their difference is 2. Last year you did that by guess and check. This year we could set up 2 equations, x plus y equals 4 while x minus y equals 2. We could graph those lines, find their point of intersection, and as you've probably already figured out, it would be 3, 1. We can also solve problems like this. This is kind of like the problem that we did with the rental car and going on vacation. Okay, so when does the cost equal the same cost as another plan, and when does it become more expensive? Those are systems of equations. Now, there are 3 different situations. To solve a system by graphing, you're going to graph both equations, find their point of intersection, and name it, and check your solution in each equation. You could get one solution, and that would be the intersection of 2 lines. Okay, that's when you're going to get one solution. You could get no solution. You can graph lines that are parallel and there would be no solution. Or you could get an infinite number of solutions. So if I had one line and then it was the same line but wasn't reduced kind of thing, then you'll find the same line takes place and then there's an infinite number of solutions. Oh, I wanted to go to a different thing. Hang on one second for me. I want to go back to this one. Okay, so if you look at this, this is kind of a little applet that you can use. Let me just get rid of this one. Okay, to show how this is 1. If you notice here, the slope of the blue line is negative 2.8 and the slope of the red line is 0.4. And then if I change this, okay, I still have one intersection except when the lines are basically parallel. Okay, it's hard to get it exactly there, but you can kind of see. I can't really get it exact. So parallel lines are not going to have a point of intersection. So we're going to label both lines, label their point of intersection, and we're going to check that. So what I'd like you to do, we're going to go to the first example, is to graph those lines. Oops. Okay? Graph those lines that you see there, y equals 2x and y equals 3x minus 3. Find their point of intersection, and then come back and check with me. So pause here and graph away. All right, if you're back with me now, these are what my 2 lines looked like. I got a point of intersection of 3, 6. Now you could see if you're sloppy why this is not going to work for you. All right, so it's important to graph your lines precisely. And those are dotted just because that's, or dashed, that's just because that's the line I use. They shouldn't be dashed, they should be solid lines. We're not doing inequalities here. So it's just to show the variation of the 2 lines. And then you check always in the original equation. So if you've had to manipulate like 3x plus 2y equals 12 to get y equals mx plus b, you would still check it in that equation. Okay? So what I'd like you to do is do the next 5 problems and then come back and check your answers. So number 2, I got a solution of negative 1, 3. Those are what the lines look like. Notice that I labeled both of my lines. I labeled the intersection point, okay, on the graph. And then a check in both equations. I would write the equation here. I would write check, negative 1, 3, and I would write y equals x plus 4. Does 3 equal negative 1 plus 4? Yes, it does. And y minus 2x equals 5. Does 3 minus 2 times negative 1 equal 5? Yes, it does. Okay? Next solution was the lines coincided. So as you can see here, they were just different variations of the same line, and you should have got an infinite number of solutions. Number 4, I had a solution of negative 2, negative 3. I don't show a check there, but it does check. I do have it on my paper, just not on the smartboard. You should have yours on the paper too. Make sure your lines are labeled, arrows at the ends, and a labeled intersection. Number 5, they were parallel lines, so no intersection. Okay? And then the last one, I got an intersection of negative 1, 0 for this. And these lines, you couldn't, oh, I had a, what was the y-intercept there? Yeah, they were kind of fractional y-intercepts, so you had to almost use a table or find the x-intercept, which is basically like using a table. Okay, so one of the lines should have been, and again, I'm going to use dash just because, let's see, this one had a slope of 3/5, and so 3/5 would be like this, kind of. Almost sort of like that, I think. It's a little off, but not too bad. Okay, so that was the 3x minus 5y plus 3 equals 0. And then the other one, and again, I did that dashed just because I'm going to show 2 different lines here. So you can use 2 different colors, you can use the same color. It doesn't really matter as long as you're labeling them effectively. The other one, let's see, kind of goes like this, I believe. And that had a slope of 7/4. So this was 7x minus 4y plus 7 equals 0. And the point was negative 1, 0. And you should check that in both equations. All right, so pretty basic. You have all the tools necessary to do this type of problem, and it's just sort of an application of that. Great job tonight. I'll see you tomorrow.